students. Hi students, good morning. How are you all? Hope everyone are fine. Good. Until yesterday, that is in the previous video, we discussed about the history of the periodic table. That means there are so many scientists who worked hard to keep all the elements in a proper manner in the form of a periodic table. Now we will go still more deeper into the concept, okay, and we will find out who exactly is the founder of our modern periodic table, okay. While this work is coming on, who is the person who came with a great idea of arranging all the elements in the form of a periodic table, and by just looking at the periodic table itself, how are we going to learn about the properties of the elements? Let us see, and let me give you a brief review about it, and then we will get back to that. Okay, this is of part 2 video, right? So here, this is our periodic table at this, that is the starting of it, and in the previous video I already told you about the persons who came with an idea that water, air, fire and earth, right? Here 330 BC, Aristotle proposes the four element theory, that is earth, air, fire and water, and in the 360 BC Plato coins the word as stoichia, means elementary principles of the world. That means elements are having some of the principles they used to follow, that those based on those we can arrange those elements in a particular type. Okay, and then Democritus and Leucippus came with a proposal that yes, they said that there is the matter around us is made up of a small indivisible particle of matter, that is atom, right? And afterwards, scientists worked a lot further, and here, to arrange these all the elements, a person called Sir Francis Bacon, he published the Proficiency and Advancement of Learning. What does it mean, children? It contains the description what about later be known as the scientific method. What do you mean by scientific method? See, there is a procedure to complete an experiment. So while we are going to do the experiment, what we have to do? First of all, we have to find out what is our aim and what are the materials required and what is the procedure we are going to follow and what should be the precautions to do, right? So what are the observations we made? These are all the things will be captured in a proper manner, in a proper order. This is the method which introduced by Sir Francis Bacon. Okay, and why are we discussing about him? Because these are all the elements, arrangement and the properties of learning should be in this way, the path showed by this person. Okay, and then afterwards 1661, Robert Boyle, they also started inventing on so many things, children. And Robert Boyle published the Skeptical Chemist, which contains the details of the earlier known atoms, molecules and a chemical reaction. It's known to be the beginning of the modern chemistry. See, he invented almost at the time of his 1661. We are known with 13 elements, 13 elements, children. 13 elements. So by knowing of the details of those all the known atoms, okay, so he has given an idea about atoms and what is a molecule and what are the chemical reactions. Here chemical reaction means reactions. Okay, chemical reactions. He gave an idea. It is known to be a beginning of our modern chemistry. That means chemistry has taken a greater path towards the modernity, okay, at his time. So he has printed that. That means there is a lot of development started in 1661 to in the chemistry. Okay, so now, and we already discussed about him, right? You remember him, Anthony Lavoisier, wrote the first extensive list of the elements containing 33 elements distinguished between metals and non-metals. So his time period has been started, of course, 1778 or something, right? So he is the person who is called as a father of modern chemistry. Clear? So why we are giving a honor to him? Actually, after the starting of the development of Robert Boyle, Antony Lavoisier worked a lot for chemistry, and then he paved so many paths. He paved so many paths towards the chemistry to get better idea about all the elements and the properties and all. So at the time of Robert Boyle, how many elements? I said 13 elements are there, and while the Lavoisier is going to work on it, it is of 33 elements. In between there are some other members also, children. We will discuss about them too. Okay, so I'm just giving a brief about it, and then I'll get back to you, right? So while these 33 elements have been discovered, he gave an idea of arranging all those elements as metals and non-metals format. Okay, he has given that idea, metals and non-metals, by observing the properties of all the elements. Now coming to the attempt to relate the elements. Now, John Dalton proposed the Dalton's laws. I hope so you already well known about this Dalton's postulates. That means atom is neither created nor destroyed, and atoms are going to mix up in a proper whole number ratio, that is the law of proportions, law of definite proportions. These are all the things has been given by John Dalton, and he composed of different elements. That means elements are having a different properties. Okay, so these are all the statements given by John Dalton. Now here the growth of the periodic table starts with Antony Lavoisier. See here. So John Dalton came up with the element along with the symbolic format. Hydrogen, see, maybe you will be get surprised by looking at these symbols. Actually, simply we are writing now hydrogen. What is the symbolic symbol of hydrogen? In the sense, simply H we are writing. And suppose like argon or something, AR we are writing. Carbon in the sense just C we are writing. Oxygen in the sense O. But at the time of them, they have invented with the different symbolic formats. Like here what you can see, these are all the things: hydrogen, argon, carbon, oxygen, phosphorus, sulfur, magnesia, lime, soda, potash, so strontia. Means these are all the names not decided, children. These are all the names not decided. Okay, so that's what it's not decided. The at that time, whatever the names are there, and those all the names and their symbols, I have given a list over here to make you understand that. Okay. Now, the time of John Dobrinier. So, he has arranged, he started, that means he is the person who started arranging into a tabular format. Okay, and at the time of his arrival, about of 1800s, okay, 1800s, at the time of his arrival, there are 13 elements, of course, of 10 to 13 elements are there. That means he started arranging the 10 to 13 elements in a form of a triad format. In a triad format. In 1829, he classified some elements into groups of three, which he called triads, as triads. What do you mean by triads over here? The elements in a triad in the sense three. Okay, triad has a similar chemical properties. That means he has chosen three of the elements which are having the similar chemical properties and orderly physical properties. Okay, and they have the order of physical properties, that means similar chemical properties, and then there may be increasing or decreasing of the physical properties. He has arranged in such a way, like here you can see the examples as chlorine, bromine, iodine, and calcium, strontium, and barium. Okay, let us go still more deeper into this Dobrinier's working, children. Then you will understand. And after the Dobrinier, Newland also came into picture, and he came up with the law of octaves. Let us see very deeply into this concept: Dobrinier law of triads and Newland's law of octaves. Okay, so these are the models of triads. Now here, in the time period of approximately of 1800s, in the time period of approximately of 1800 onwards, the journey started of periodic table by Dobereiner first thing. Okay, and we are only there are so many scientists work, children. I will talk to you later about them. Now here he has arranged the elements into triads format. That means the group of three elements. Group of three elements. So how he arranged those all the group of three elements? He arranged randomly. He arranged randomly. Are you sure? No, he doesn't arrange randomly. He has arranged in a proper order. Let us see. Let us take an example. That is, suppose there are three elements which are grouped together as the triad format. That means he has observed the atomic masses of those elements. And the first element and the third element's atomic mass average will become the second element's atomic mass. Are you getting my point, children? The first element and the third element's average of atomic mass will give the second element's atomic mass. Okay, clear? So this is the basic principle of the Dobereiner, who came up with an idea to suggest as a triad. Okay, so now let us see the better examples. That means whatever he has arranged the triad, see here. Lithium is having the atomic mass as 6.9 and the potassium is having the mass of 39. So what is the average of these two, children? The first element and the third element now. So what is the average of this? Yes, 23. So the atomic mass of sodium became 23. So he arranged in that format. Means lithium, sodium and potassium. He arranged into the form of triad format. So, but of course it is not perfect enough. Of course, he has suggested three sets of triads, children. Three sets of triads like this. Okay, lithium, sodium and potassium. And already I showed you two more before. Chlorine, bromine and iodine. Calcium, strontium and barium. But these are only suitable for few of the elements. This law is not applicable for the rest of the elements. It is not at all, not became possible. So what to do then? If it is not possible, what to do? Then there is a person came with an idea of octaves, and these are the elements. Here I have to tell you one more thing, children. I have to tell you one more thing about the Newland. He is the first person to give the elements the number. Elements a number. That is what the atomic number. Till now we are just discussing about the atomic masses of the elements until almost the end of the periodic table. Okay, while the Newland has been joined, okay, while he is going to be introduced, there are 56 elements, and these 56 elements he has arranged in the increasing order of their atomic masses. After arranging them as the atomic masses, he has simply numbered it, but there is no idea of atomic number at that time. Only they are considering the atomic mass itself. Clear? So how he has arranged? He has arranged with the help of, that means, see here in the music also we used to see sari gama padani sa, like that. That means the first letter and the eighth letter we came with the same tune. Am I right? So that means it repeats after a particular interval of time. That means the same note will repeat after a particular interval of time. So based on that, so here in their language, the sarigama padani is our Telugu language. He do re mi faso la ti. So again it repeats with do. That means whenever he arranged all these elements, whenever those are kept in the tabular form like this, the first element and the eighth element are having the similar properties. The first element and the eighth element are having the similar properties. He arranged in that way. Total 56 elements are there. So he started arranging. Okay, he started arranging. How he had arranged the elements? He arranged the element according to the increasing order of their atomic mass. Increasing order of their atomic mass. So the first element's property has been repeated with the eighth element. Eight in the sense oct. That's what it became, the law of octaves. It is given by Newland. That's what Newland's law of octaves. But this idea does not work to all the 56 elements. It is worked until only calcium. He could arrange up to calcium. The rest of next properties of chromium, titanium, these are all the elements. Of course, he arranged, but those properties did not match the previous elements. Okay, so that means it is not applicable for after calcium. Okay, for the elements after calcium. So Newland's law of octaves also dropped down. Means, see here, the Doverinia dropped down with his law of triads because it did not work only 3 groups of elements as he has arranged. And now Newland came into picture. He also arranged, and here cobalt and nickel he grouped into one category, and here fluorine, chlorine, bromine are having the similar properties, and cobalt and nickel is having a different property, and these two elements has been grouped into same box. Okay, that means the same column. Means they don't the missimilar properties elements has been arranged. So here he has even the drawbacks here. He also having drawbacks. Now Mendeleev came with a greater idea. He having a systematic approach to classify the elements, and he is the founder of the modern periodic table. That means he gave a great foundation for the modern periodic classification. So he has worked a lot and lot, children. So let us dedicate some of the time to Mendeleev. Okay. See here, this is our John Newlands classification. You can see over here, right? Here you are. Lothar Meyer. And why are we talking about Lothar Meyer? Of course, he's not successful towards the periodic classification, but he published his own periodic table along with Mendeleev. However, Mendeleev has been arranged his periodic table of elements in the same way Lothar Meyer also came with the same idea. But here it is the contribution of Lothar Meyer has not been recognized because he did not able to explain completely about what he has arranged in which way. Okay, most probably. So we are going to talk about Dmitry Mendeleev, who is called as the genius. I used to call him as genius. I'm going to hats off him for his contribution towards the periodic classification. Why am I telling the genius? Let me tell you the facts about the Mendeleev. You will also say that yes, definitely he is a genius. Okay, so why are we discussing about all the contributions of the scientist children? So we should know the hard work of our scientists, and we also should get inspired by them. Okay, let us start knowing about him more and more. So Dmitry Ivanich Mendeleev. Dmitry Ivanich Mendeleev. When he started experimenting, there are so many elements, and see here children, there is a small story what he has done exactly to the contribution of the modern periodic table. See, at the time of him, there are 63 elements are being discovered. So he started experimenting on each element, children, on each element's chemical and physical properties. Okay, each element's physical and chemical properties has been taken into consideration. How he has taken that into consideration, and I have shown you a card like structures. These are all the properties of physical properties and the chemical properties he has written on those cards. How he has written on those cards is, there are small cards, right? So these 63 elements react with the standard elements. Okay, these 63 elements react with the standard elements like hydrogen and oxygen. That means at that time, these two, the oxygen and the hydrogens, these are the two elements which are seems to be as highly reactive elements, which are considered to be as highly reactive elements. That's what he started. Yes, they are ready to form compounds. Form compounds with the most of the elements. That's what, while these are reacting with these two elements, how will be the composition of the compound? He started experimenting on it. And after the experimentation, all the elements, physical and the chemical properties, he has written with a symbolic form on the top of the card in the circular form, and then atomic mass and its physical property and the chemical property in the form of a formula. Okay, and then how to arrange all these? Then he started thinking, okay, how to arrange all these. Then he arranged in such a way that increasing order of their atomic masses, as Dauberinier did and as Newland did, and even the Lothar Meyer did. So he also arranged. But here, if you observe, there are some spaces left. Why he left some spaces? Increasing order of atomic in the sense, atomic mass in the sense, we can keep them in that order, right? Why we have to leave the space? Here, this concept make him genius, because these elements had to be discovered. Means he is a he can see the future, I hope. He can see the future, I hope. See, the elements will be discovered. He has left some of the places. Okay, in this place, the element will be discovered with these properties. Means he already guessed it. He guessed before the invention of elements itself. He guessed the properties of that element exactly. Yes, this will be that particular element. Afterwards, of course, yeah, this element has been discovered. There are discovery of elements with the same physical and chemical properties told by Mendeleev. Did you understand what I mean to say? So, recurrence of the physical and the chemical properties That means whatever the places he left, in that particular places, he suggested some of the elements with the physical and chemical properties. Okay, and those elements has been discovered with the same physical and chemical properties and even with the approximately of the same atomic masses. Then we have to say that he is a genius, right? Now he proposed a periodic law, that is properties of elements are periodic functions of their atomic masses. Means he has arranged all the elements based on the atomic mass of the elements. Means the properties of the elements in the sense physical and the chemical properties. These physical and the chemical properties are the basic functions, that means those which occur at the regular intervals. See, the elements which have been arranged one below the other, right? That means the total column elements, are having, yes, the total column elements are having the similar chemical and physical properties. So that's what he has arranged in the increasing order of the atomic masses. So here it is an idea of modern periodic table. Of course, the similarities in the physical and the chemical properties at the regular intervals. Regular intervals means this is the idea came from the Newland, isn't it? Repeated after the regular time interval. The element property has been repeated after the regular time interval. So, Mendeleev laid the foundations for the modern periodic table in this manner. Am I so clear to you, children, about the Mendeleev? Of course, he is a genius because he, before itself, he predicted the elements beforehand with along with the properties, children, along with the properties. We can't imagine even. Am I right? Suppose the element has been discovered. Okay, the element has been discovered. Afterwards, we are going to do something with it. That's fine. But in the beforehand itself, he predicted the element and its atomic mass and properties, and then after some of the years, yes, exactly that same atomic mass and the same physical and chemical properties elements has been discovered, and then those are exactly arranged where he left the places, exactly. Okay, so such there's some one example I will tell you to make you believe. There is an element, he said that there is one place in the periodic table, there is an element. If we keep that element in our hand, it used to melt. That means it is having a melting point below our body temperature. What is our body temperature? Exactly 37 degrees Celsius. So below our body temperature, the object used to melt. That means that much low melting point it has. Okay. Afterwards, it invented even with the name called gallium. The gallium is the element when we kept in our hands, it used to melt. That means it is having the lowest melting point. Got it, children? I hope so you understood. Of course, having the achievements, having greater achievements of a modern periodic table, these are the great contributions make him the genius. The genius. Only geniuses can predict before, right? So that's what. Hats off to him. And the basic modern periodic table is the idea of Mendeleev only. That's what I'm calling him as a genius. I'm giving hats off to him. Okay, right. Now let's see. Of course, there are so many achievements, but there are some limitations too. What are those limitations? Let us see now. So here, this is a contribution of the modern periodic table. Here is the Mendeleev's periodic table. He arranged these all the elements like this, right? So when he started arranging all these elements, afterwards there are a lot of elements which have been discovered. Okay, and they started arranging all these elements. Some of them could not match, children. Some of them could not match. Whenever it has been introduced, like he did not give, there are some major limitations of Mendeleev's table. He arranged the element hydrogen, especially the element hydrogen is a non-metal, and this hydrogen has been kept in the group of along with the group of metals. Why he is unable to answer. And then that means according to the properties he has arranged, but he could not able to answer why it has been arranged over there. And then while we are going to find out, that means the modern periodic law, that means the Mendeleev's periodic law, to be modified to arrange the next elements what has been discovered. Of course, he left some of the places, but later on still more elements have been discovered. Then for those elements there is no place in the Mendeleev's periodic table. That's what. Now here in 1913, Henry Moseley came up with an idea of saying about the properties of the chromium. No, it is not the properties of the element like chromium, not based on the atomic mass, it is based on the atomic number. Just a second, children. Till now we are discussing about only atomic mass. Now he came up with an idea of atomic number. Yes. So randomly assigned a number. Simply he randomly assigned a number. That is what? 24. Right? Is it? Is it he randomly assigned the number? No, not yet. Because that 24 gives out about the number of protons present inside the atom. Then this Mendeleev's periodic law has been changed, and number of protons present in the nucleus of an atom of the element will be given as the number, as the atomic number. That means that is the atom number. Okay, so how many number of protons are present inside the atom? It is going to give us the idea about the atomic number. Till now, no one introduced about the atomic number at all. Everyone are discussing about only atomic masses of the elements. He is the first person to say that the properties of all the elements are the periodic functions of their, not the atomic masses, it is of the atomic numbers. That means the number of protons present inside the nucleus. That means inside the nucleus, whatever are the protons present, those will affect the properties, the physical and the chemical properties of the element. That is what this Mendeleev's periodic table has been taken out, and then it has been arranged with atomic numbers, not with the atomic masses in our modern periodic table. So this is a great contribution towards our modern periodic table by our scientists. So coming to the modern periodic law. So who said this modern periodic law? It is said by Henry Moseley. He is an English physicist. Okay, actually properties of all of properties of elements are periodic functions of atomic numbers. Numbers, children. Until now everyone said about atomic masses only. Here Henry Moseley completed his modern periodic law by stating that these are the functions of their, that means the properties of the elements are the periodic functions. Periodic in the sense it repeats after a particular interval of time. Okay, so those because of their atomic numbers, not because of the atomic masses. Clear? So based on that he has arranged. Now 1, 2, 4, there are 4 elements. So third element with a number, it came into a proper order. So overcoming the limitations of Mendeleev's table, children. The limitations of Mendeleev's table are the first thing about the arrangement of the hydrogen. Arrangement of the hydrogen, that is what the position of the hydrogen. So why that hydrogen is left there itself? Because yes, this is having the atomic number 1. That's what it left in the first place. It is left in the first place, right? And he has given, Mendeleev has given it his periodic table with 7, however is the number of rows and number of columns, the same thing has been taken. Now the second drawback of him is position of isotopes. Position of isotopes. Isotopes in the sense what, children? Of course, their hydrogens are three hydrogen are having total 3 isotopes, and carbon is having, of course, 2 isotopes, carbon 12 and carbon 13. Okay, they are having atomic numbers the same atomic number but different mass numbers. So here in the first one it is 6 plus 6 total 12 is the mass number, and here in the next one 13 is the mass number. So these are all the isotopes. How to arrange this in this table? It is not required, because this our modern periodic table is based on atomic number. So in that atomic number itself only 6 is the atomic number for both of them. Okay, carbon 12 atom or carbon 13 atom. So carbon atom itself, in the place of carbon atom itself, the isotopes also will occur. So that's what atomic number is equals to number of protons. Based on the number of protons, it has been exactly arranged. Am I very clear to you, children? Real, right? So possible to place the isotopes now. Clear? Whatever is the element with the mass numbers. Okay, so mass numbers we are not going to consider, and atomic numbers we are going to consider. So the same atomic number has been grouped into only one. Now chlorine, there are 2 isotopes of chlorine, one is 35 and one is 37. So both are having the same atomic number, right? So these 2 are grouped together under only one, the same atomic number. So they have placed at only place of 17. Okay, placed together as a single element. Now prediction and the placement of undiscovered elements. Prediction and placements of undiscovered elements has been done by Mendeleev, right? So some of the elements predictions, that is based on the atomic masses of the elements. Of course, he arranged all the elements based on the atomic masses, but a few of the elements atomic masses are small mistakes are there. Okay, so atomic masses of the elements not arranged in the increasing order. Here you have to identify one of the thing. He did not arrange, he said that I have arranged all the elements in the increasing order of their atomic number, atomic masses. Who said? Mendeleev said. But this arrangement has been disturbed in few of the elements. Means suppose 1 2 3 4 like that, he has to arrange at the atomic masses, but he arranged 1 2 4 3 like that. Why you kept 4 in before and 3 in the next? Why not 1 2 3 4 you kept as you said? If we asked, he is unable to answer, because this is based on the properties. Of course, he predicted the position of the element, but he is unable to answer because that time he didn't know about the atomic number clearly. So that's what here is the arrangement 300, 299 and 297. So but he arranged in such a way that 300, 297 and 299, it is not exactly right, it is not exactly what he said, but he arranged in that way. He arranged in that way, not arranged in the increasing order. Why? In the sense what? Why means atomic number is in the increasing order, as that has been cleared by Moseley by introducing the atomic number of the elements. So prediction and the placement of undiscovered elements as the not in the increasing order of their atomic masses. If we place them in the increasing order of their atomic number, yes, whatever he predicted is perfectly fine. So in this way, the drawback of Mendeleev has been corrected by the modern periodic table. Clear? So atomic number of elements are been arranged in the increasing order. Perfectly fine. Perfectly fine. Now it has been arranged in the increasing order. Based on what, children? Based on, yes, simply atomic number. Based on atomic numbers. If you observe all these things, you know, you will get an idea even. Right? and the drawbacks of Mendeleev's and the modern periodic table. We, of course, in this we have come across with all the modern, based on the modern periodic law, we have already understood about this is based on our atomic number. Am I so clear, children? This is our modern periodic table. It is having, there are so many number of rows and number of columns, isn't it? So in the next class, that means in the next video or in the next class, we will discuss still more deeper into, we will discuss again briefly about the Mendeleev's drawbacks, and then we will discuss about the modern periodic table classification. Okay, and then we will get back, I will get back to you how these are being arranged and what are the properties of all these elements in the periodic table. Okay, children. That's all for today. Thank you so much. Bye, children. Take care and try to revise everything and try to inspire by our great scientists. Thank you so much. Bye.